It's really bad for me, but I love sweeties. Of all colors, shapes, form, taste, smell, I can't resist. Even the licorice one that disgusts a lot of people. I'm especially fond of the banana-shaped ones. But did you know, these have actually never seen a real banana in their production? Nope, the taste, the smell is entirely synthetic. Inspired by nature, but completely man-made thanks to a chemical reaction. But what delicious chemicals are hidden behind these tasty sugar treats? You don't have to look very far. 2 of your already well-known family of carbon compounds are involved. Forget the diet, let's eat. This is Think 4. Esters are a family of organic molecules produced when the hydroxyl group of an alcohol reacts with the carboxyl group of a carboxylic acid. The compound newly formed will present the ester link, and water is the other product formed in the process known as condensation reaction. Esters will get their composed name from the alcohol and the carboxylic acid they come from. The first part derives from the alcohol part with the ending -ile. For example, if ethanol is used, the name of the ester will start with ethyl. The second part of the name comes from the carboxylic acid, used with the ending -oate. So if you use methanoic acid, the second part of the ester will be methanoate. The complete name for an ester made out of ethanol and methanoic acid will then be ethyl methanoate. Esters are extremely easy to make, and an easy method can be followed to produce them. We start by gently heating a water bath and a mixture of equal volume of alcohol and carboxylic acid with a few drops of sulfuric acid. After a few minutes, it is removed from the heat and mixed with a solution of hydrogen carbonate to neutralize the sulfuric acid. Carbon dioxide is given off in this neutralization reaction. Esters are immiscible, so they will naturally separate and form a layer at the surface of our solution. You will know that your experiment is successful because esters are scented compounds, and a characteristic smell will emanate from your product. This experiment tells us a lot about esters and what their properties can be. Common alcohols and carboxylic acids are soluble in water, while esters are immiscible and will form an oil-like layer on top of an aqueous solution. This is because of the presence of polar OH bonds in alcohols and carboxylic acid that will make these molecules soluble in the water-based solution in our experiment. Esters are so much more volatile than alcohol and carboxylic acid they derive from. This comes from their relatively low boiling point. But how can a compound made up of 2 molecules have a lower boiling point? Ethanol, 80 degrees, methanoic acid, 100 degrees. So how come ethyl methanoate boils at only 54? This is due to the presence of hydrogen bonding in the 2 parent molecules, which will make them have a relatively high boiling point compared to their ester offspring, which do not have an OH bond. Esters are used in a wide range of applications, but most noticeable is their use in scented products like perfumes and flavoring used in the food industry. Less visible, but much bigger quantities, it's their use as a solvent. They're able to dissolve many non-polar substances, and because they have a low boiling point, they tend to evaporate quickly, which makes them ideal for paint and nail varnish. And here it is, 3-methyl-butyl ethanoate, the flavor known as banana oil, which occurs naturally in the banana plant, but is also produced synthetically for the food industry. But it is not the only artificial flavor. If you've ever eaten a sweetie with pineapple, orange, apricot, pear, you definitely have tasted artificial flavoring coming from esters. So next time you indulge in a packet of your favorite sugar hit, you can thank chemistry for the sweet taste of success. This was Think 4. Thanks for watching.